Assalamu alaikum, guys. Today in this lecture we will do power. It's the second lecture of our topic of our chapter power, energy, power, and work. Okay, so let's start. So, what's the definition of power? Definition of power. So, the definition of power is the work done in a unit time. Okay, work done in a unit time. It's one of the definition power. So another definition of power can be the rate of change or the rate of doing work. Okay, the rate of doing work is also called as power. And third definition can be the rate of energy transfer. Okay, the rate of energy transfer as well can be noted as energy transfer. Okay, so all these definitions are related. That work done in a unit time, or the rate of doing work, or the rate of energy transfer. Okay, so we are done with the definition of power. Now let's write the symbol of power. Okay, symbol of power. So what's the symbol of power? Symbol of power is P, capital P, and power is a scalar quantity. Okay, is a scalar quantity. So power is also related with energy and work. How that for work we need we need energy, and when we do work, it is called as power. Okay, so this is how they are related to each other. Okay, so when we are done with the relation of all these things, now what is the formula of power? So power is equal to work done upon time. Okay, work done upon time, and work done means energy. Okay, means the energy. We can also write it like this: energy upon time. Okay, so either it's P is equal to W upon T, or it's P is equal to E upon T. Both are the correct words. Okay, but we usually write P is equal to W upon T. Okay, means work done upon time. So when we write P is equal to W upon T, work done upon time. So what can be its unit for work done? Work done unit is joule. Okay, and time unit is seconds. Okay, so its units can be G upon S, and this is also known as watt. And what is watt? Watt is SI unit for power. Okay, SI unit is equal to watt. This is the SI unit of power. So, how to convert watt from watt to kilowatt? So, what do we do for converting watt to kilowatt? We divide it by 1,000, or we divide by 1,000, or write an exponent 10, exponent minus 3, okay? Before the any value like 1, like 10, exponent minus 3, or this is kilowatt, okay? This is kilowatt. This is how we convert it to kilowatt if needed only. So now we are done with the basic things, basic of power. Now let's do some questions, some past paper questions, which are frequently tested. So let's do the first question. Okay. So there, let's suppose here's an object. Okay, and an object of mass 20 kg. Okay, and it travels at with an acceleration of 2 meter per second in 2 seconds. Okay, 2 minutes. 2 minutes is the time taken, and distance covered is 25 meter. And here the question is calculate the power in kilowatt. Calculate the power in kilowatt. So how do we calculate? So first, what we have to do, calculate the power in kilowatt. First, we have to calculate. the F. So what is F? F will be F is equal to MA, right? So F is equal to 20 times 2, and hence it will be 40. Okay, this is how we are going to write. How first we will calculate F. Then what we'll do? So then what we'll do? We'll calculate power. So what's the formula of power? Power is equal to W upon T, right? So P is equal to what is the work done? Work done means FD means 40, and distance is 25. So 40 upon 20 multiplied by 25 upon time which is 120. So the answer will be like, so let's cut and it will be like, so the answer is, let me check it. It will be 8 8.31 times 10 to the power of minus 3 kilowatt. Okay, well, if it isn't, if you don't put it in kilowatts, then it will be 8.31. But here it is hours powers in kilowatt. So hence 10 exponent minus 3. Where we can look, it is say that calculate the power in kilowatt. So we have calculated the power kilowatt here. 10 exponent minus 3. Okay, so now let's do another example. Example number 2. Example number 2. Okay. Okay, so let's take here, it is a car. Okay, it moves, and here is also a car. Let me write the question. So we so I've written the question. So in this question, first we have to calculate force, okay, and then distance. Well, the distance is given. So first we have to calculate the force. So what is force? F is equal to ma, right? F is equal to ma. Hence, first we have to calculate m. So the rotational free strength is given 9.8. So hence we will divide it 3000 divided by 9.8, which will be 306.12 kg. Okay, so this is the mass. This is the mass, and now we will calculate acceleration. So acceleration is equal to u minus v upon t, right? So a will be 30 minus 0 upon time is given 20 seconds, right? Okay, let me see the time. Yes, it's 20 seconds, velocity is 30. It's a is 0. So 30 minus 0 upon 30, so acceleration will be 1 on number 1 upon 2 or 1.5. Okay, so now let's calculate F is equal to ma. So F is equal to m is what was m? M was 306.12 multiplied by a is 1.5. So by this we get F, which is 459. Okay, we have found F. Now let's go on to the formula. W is equal to F, F into D. So in this formula we have found F, and D is also given. So now let's calculate it. F is 459 multiplied by 125, and by this we found it 357397.5 watts. Okay, 0.5 watt. And this watt, what do we have to do to convert it in the to convert it in kilowatt? We will, what do we do? Yes, we will place an exponent which will be times 10 to the power of 3 kilowatt. Okay, so this is how we have done it. Okay, guys, thank you. Oh, I forgot to place 10. 20 means the time upon, because affinity 20 is the formula for power. So after this is the answer. I hope you guys understood this question. Okay, so this is how we find the power in this question. So we are done with the second example. Yes, so let's So that's it for today, guys. I think that's enough for today, and we will continue energy unit in the next video. I hope you like this lecture, and do share, like, and subscribe, and share it with your friends who are facing problems in chapter power. Okay, this chapter power. Wait, let me. And if you have any problem with it, so do write comments if you have any problem, or if you like the video, so do write any comments. So that's all, guys. Thank you. I love this.